Welcome to the Room 1 session. For this session, we're doing the Scrape the Web for Fun with Nonprofit with Python, and this is going to be hosted by Wes Novack. Please remember to post all your questions in the Room 1 or the Slido room, and we'll take all the questions at the end. Wes, if you want to go ahead and take it over.
Yeah, thanks, Zach. Hello, everybody. Welcome to my talk, Scrape the Web for Fun and Nonprofit with Python. So this presentation, just to quickly set expectations here, I'm going to have a couple slides, but the majority of the time will be spent looking at some Python code and talking about what I learned while I was building this project. So again, because of the format here, we ask that you post questions in the Big Mountain Data and Dev Room 1 Slack channel. And at the end of the presentation, I will field those questions. So let's jump right into it. Again, my name is Wes Novack. I'm a director of platform engineering at a technology company headquartered here in Utah. And this is my presentation. So what is this project? The project I'm talking about here in this talk today is a web scraper. It runs on a schedule and it posts about free learning content to Slack. So why did I start this project? Well, primarily when I first started it was to help myself learn and to solve a problem that I had. So I'm going to go into the details on the problem I had, and the majority of this presentation is just talking about some of the things I learned while building this project. So my hope is that as you join me throughout this presentation and this code walkthrough, is that you learn at least one thing new from what I'm presenting here. So the problem. So there, a couple of years back, I discovered this website, pactpub.com, and Pact is a publisher of technical learning content. Particularly ebooks is their main type of content that they publish. And they had this free learning webpage where every 24 hours they would post a new free title of the day. Most of the time it's an ebook, sometimes it is a video. And they made it available to anyone with an account to claim that title, but only within a limited time window of 24 hours. So when I heard about this, I thought it was great. I was checking the website almost every day so that I can grab a ebook that I was interested in. If the free ebook of the day, free title of the day matched up with something I was interested in and something I wanted to learn about, I'd grab that title. But I got tired of checking the website every day. So I started thinking about how I could automate this and potentially take this data from the free learning webpage and post it somewhere that I lived and worked and had more visibility into in my day-to-day. And for me, that was Slack. So I wrote a Python utility that will, on a timer, on a schedule, on a cron job, what have you, it will check this web page daily and then post what it finds to a Slack channel. So you can see here on this slide, this is an example of one of the posts to Slack that it does. It grabs the title of the day, it grabs the title of that content, it includes a link to that free title page, and it also includes a cover image for the ebook. So I'm also posting these in the Utah Geek Events Slack team. So if you'd like to see what this looks like, you can join the Learning-Alerter channel inside of the Utah Geek Events Slack team, which is where this conference is hosting all of its Slack rooms and channels. So some of the things I learned, just to briefly go over a couple of the things. I learned how to organize Python code. I learned how to test with PyTest. I learned about integrating with Slack in multiple different ways. I learned how to log. I learned how to containerize it with Docker. I learned about PEP 8 conventions. PEP 8 is, PEP stands for Python Enhancement Proposal. Number 8 was one that was published many years ago, and it contains guidelines for Python code style. So how to format your Python code when to use particular formatting here and there. And PEP8 is a convention that's followed by many Python developers and many Python code bases, or at least most parts of PEP8. Some parts are a little more debatable and not followed as widespread as other parts of PEP8. But we'll get into a couple of the PEP8 conventions that I learned about as I wrote this code. All right, so let's switch to code. And again, I'm going to be going through Python code for the majority of this presentation. So I'm switching here to Visual Studio Code, which is one of my preferred code editors. And I've got my Learning Alerter repository open here. So one of the first things that we can look at here is the tree structure of my code base to give you a idea of what this looks like. So I'm using the GNU tree utility here, using that -L space 2 flag to tell it to look 2 directories deep to give us an idea of what this code base looks like. So you can see here we've got some files in the root of this repository, and then we've got some directories underneath that, one for packed, one for Slack, one for tests, and one for venv, which is my virtual environment. So those are the most important things. The virtual environment does not get checked in and is defined in my .gitignore file, so that doesn't get managed by Git version control. So when talking about Python code, you need to know what the terminology is. So to quickly cover some of that, a Python file ends in the .py here. Some of this is a little bit introductory, but I'll quickly cover it. But a Python file is a .py file, and Python calls that a module. A directory that contains Python files is called a package. So in this case, looking at the tree structure here, you can see I've got this packed package and this free _ title.py module underneath it. So that's important to know the terminology and how to reference Python code from different modules inside of different packages when you're using import statements. Okay, so you've got a little bit of idea on the structure of this Python project, of the different packages that I have defined in this project, and some of the different modules. So let's dig into the code itself. So I'm going to clear out my terminal down here, and then we can look at the main.py file at the root of this project. So up at the top of my main.py file, this is the entry point for this project. This is what we target and we execute when we're going to run this program. You can see I have various groupings of import statements. And this is part of the PEP8 Python code style guidelines. You can see here I've got 3 distinct groupings of Python import statements here that are separated by a new line. And this is defined in PEP8, where they recommend that you group import statements from the Python standard library together, and then you group Python packages that are third-party packages outside of the Python standard library in a grouping, and then they recommend that you group other packages that are within your project or local packages in a separate grouping here. So that is one of the conventions I learned about while writing this, is to how to group your import statements according to PEP8. As we move down this, you can see that I've got on line 10 and line 11 here, I've got a few constants. And these constants, that's another PEP8 convention, is to use uppercase, snake case naming for your constants in your Python projects. So I've got one here for log max bytes and one for log backup count. Another thing to mention here is that you can see here I've got some underscores in my number, in my integer here. And that's something that was added in a few versions ago in Python to help with readability of long numbers. You can see if I delete those underscores from there, it's not quite as readable as to what exactly the precision is on that number. Is it in the billions or the millions? Once you add back in those underscores, it drastically helps with the readability, and you can clearly see that now this number is 524,288,000 bytes. All right, so let's jump over into the main function on line 14. This is the entry point for this program. If I scroll down to the bottom of this file, you can see we've got this if dunder name equals dunder main, execute the main function. So this just tells the Python execution environment that if this Python code, this file is executed from the command line, that you should execute the main function as the entry point of the application. So jumping back up to there, the first thing we do is we set args equal to get args, which is another function I've got down below here. So let's jump down into get args and take a look at that. Here is our get args function, and we are using a third-party package called config arg parse, which we saw above here in the import statements when I was talking about the import statement grouping. So config arg parse, it's a third-party package. I really like config arg parse for a few reasons. It was recommended to me by a colleague, and one of the powerful things about config arg parse is that it supports just about any way that you can think of to pass options and parameters to a Python program. So it supports parameters via the command line flags like this. So if you call this Python file and you append -- slack token and some value after it, it supports that way of passing config, but it also supports environment variables. So if I want to execute this in a Docker container and pass it environment variables for config, it can do that as well. And that's one of the reasons that I chose this library for config, because I knew I was going to start out by calling this via a command line, but I knew I wanted to move it to a Docker container eventually, and that is just what I did. And now that I'm executing it via Docker, I can, in a container, I can easily pass the config options to it with this config arg parse library. It also supports passing config via config file, but I don't use that functionality of config arg parse. So just looking at this get args function, you can see I am creating this config object here, calling config arg parse.arg parser, and then I am adding configurations to that object. So I'm going to add this Slack token if it's present. I'm going to add the Slack channel if it's present. And then over here, I've got a Boolean option. That's defined here with this action equals store true parameter, so that if this packed config option is passed into the program, that gets set to true. And if it's not, it's going to be false. I've got a log level down here. You can see it. You can also set defaults with config arg parse, which is really nice. I've got a couple of default settings here, so that if that config option isn't passed into the program, it will just use some sane defaults there. And then another one down here for Slack webhook. So I'll talk about that a little bit later. But after that, we've got a call to config.parseArgs, and then we return args. So that's how we do our initial setup in this program of setting all of our configuration. We do that up here within the main function here, and then we go to setup logging. So if we go down to, and we pass in the args now that we just created. So if we go down to setup logging, you can see here we're using the Python standard library, logging library. We're setting up a basic config. We're passing it a log level from our args that we just set up with config arg parse, passing it a file name that we set up with config arg parse, and then we specify a logging format over here. The next thing we do is we're creating a handler, and this is something I learned in the process of building this project that is very helpful, that the built-in logging package within the Python standard library supports this rotating file handler. So a rotating file handler allows your Python application to manage the log itself. So we're going to tell it, this is where the log file is located that you're going to manage. It can grow to a maximum bytes of log max bytes, and that was that constant that I showed above, which translates to roughly 524 megs. and you're going to keep a backup count of log backup count. And that was the other constant that I showed above previously. So for this program, it's always going to set up this rotating file handler. It's going to look at the log file that you pass it. It's going to allow that log file to grow to a maximum of 524 megs. And when it reaches that size, it's going to rotate that log file, and it's going to keep three backup logs before starting to delete older log files. So that's really helpful so that you don't have to use a third party utility like log rotate or some other log management application to ensure that your program doesn't fill up your entire disk on your local machine or wherever you're running your program. And the Python code will manage that log by itself. So then we get the root logger and we return the root logger. So we've got this logger set up, we've got a rotating file handler, so we're all set on loggers. And then going back over to the main function, you can see we've got an if statement here, if args.packed. And if you recall from what I was mentioning previously, that packed parameter is a Boolean. So this if statement is going to evaluate to either true or false. If it's true and we've passed in that packed parameter, then it's going to traverse into this if block and execute this next line of code here in line 18, where we are getting a title and an image from packed.free_title.main. And so what is this and where is this coming from? Well, if we scroll back up and look at our import statements again, you can see up here in our import grouping that is specifying local packages, we are importing from the packed package, and that corresponds to my packed directory here in my program structure, and then the dot notation referencing the module within that package, so the free title module. So down here where we're calling it, we're referencing the package, the module, and then the specific function inside of that module that we're calling. So let's see how we actually get that title and the image by opening up that free_title.py Python module over here. All right, so here we are on this other module, and you can see I've got my import statement groupings again. At the top, my top grouping is imports from the Python standard library, and my second grouping of imports here is for the requests third-party library. And then I have a few different constants defined here at the top of this module. This top URL root constant is something that I learned about or discovered while building this project. And I guess I should take a pause real quick here to talk about sort of how this project evolved and the time I've spent on this. This project started probably about 2 years ago. I wrote it by looking at the free, packed pub free content learning page that I showed earlier, and by inspecting the page and trying to figure out where I could pull the title and the image from. And at one point, the scraper completely broke, and then I rewrote the whole thing from scratch again. So in terms of like solving problems and rewriting it, this services.packedpub.com URL is one of the things I found when sort of inspecting that web page and figuring out how is it possible for me to pull out the title and the image from that page, because it wasn't as simple as just finding a image tag on that web page. They didn't actually expose that. So you have to actually figure out where to get an image for the free title of the day. So this URL root is the start of that journey for me, in that it helps me to determine the unique product ID that corresponds to the current free title of the day. And then I also have this backup image here defined as a constant. So if I click on this backup image, let me show you what that looks like, and I'll talk about sort of why this backup image is even in the code here. So this is what the backup image looks like. I had some problems when I initially wrote this project in terms of it not always finding an image, or unable to download an image from an image URL I did find. So I wanted to have a backup image so that something got posted to Slack, some kind of image, even if we couldn't find an appropriate like ebook title image. So we'll talk more about that backup image a little bit later, but just wanted to touch on why that's there. And then the headers constant here, are just really to get around some blockages that Pact had put on their APIs that was preventing my code from executing and getting a response. Okay, so let's dive into the main code, the main function here. And again, if you recall from back in our the root of this project, we're calling this main function in the free underscore title module. So what the main function does is first it tries to get that product ID calling our get underscore product underscore ID function. And it sets the product ID into this variable here. So what does that function do? Well, let's take a look. Again, that URL at the top of the page is a URL that I discovered I could easily query the API to pull out that unique product ID from the Pact side. And this function does just that, but it requires a date range. As you can see up here, it's got this fragment of the URL root has the date from, and then down here, when we construct the full URL, I've got a date to section as well. So what we have to do is construct today's date and construct tomorrow's date and stick it in that URL to determine what the product ID of the day is from Pact. So I did that using the Python built-in date time library. We converted that to today by using now.date. We log it, and then to calculate tomorrow's date, we use that date object and we add it to the delta of days equals 1 to get tomorrow's date. So now that we have the today and the tomorrow date, what we can do is construct that full URL. And from that constant above, we use that URL root, we stringify today plus a timestamp of midnight, since the timestamp doesn't really matter for my purposes. And then and the date to equals tomorrow, plus again, that timestamp of just midnight that didn't really matter. So now that we've constructed our full URL, we can use the requests library here to do a get method against the Pact API, passing it that URL, our headers, and we store that in a response object. We log the response.text that we get back, and then from there, we call our get ID from JSON function and pass it the response.text. So the response.text is going to be a JSON API response from Pact, and we have to parse that response in order to pull out just that product ID that we're concerned about. So if we go down here to line 31, you can see what our get ID from JSON response get ID from JSON function is doing with that response text. What we do is create a product dict or a dictionary by using the Python built-in JSON library using the .loads method, and we pass it that response.text to create a Python dictionary. And then we pull the product ID out of that dictionary using the data key, the 0th element beneath that, and the product ID key underneath that. So that gives us that unique product ID that we need for future calls to Pact to determine what the title is and what the image is for the free title of the day. So we log it, and then we return the product ID, and that brings us back up to here where we have the product ID set now in this variable, and then we return the product ID. So that brings us back up to the main function. So now we've got the product ID set in our product ID variable here underneath this main function, but we also need to get the title and the image from Pact. So we're going to create a variable for title and a variable for image. We're going to call our get CDN data function and pass it the product ID. And let's go down to get CDN data to look at what it's doing there. So again, we pass get CDN data function the product ID. We start with by constructing a URL here, and this again was just a URL that I found based on discovery and looking at the source, using Chrome developer tools to see what that free title of the day webpage was actually doing, what it was making calls to, led me to find this API endpoint. So I construct my own custom API endpoint using this base URL plus the product ID that we just pulled out of a separate API, and then this /summary path. So we've got that URL there. And now we set a response object equal to request.get URL headers and with a timeout. Important and recommended to always use a timeout when you're using requests so that your Python code doesn't hang indefinitely or for a very long time without you being able to understand why. Then we log it, we log the response we get, and then we load a details underscore dict dictionary from the response that we get. And then from there, it's as simple as loading setting a title variable equal to the value of that details dictionary title key. So we get the value out of that dictionary for title and set it as our title. We log it. And then the more interesting part or more complicated part about this is the way that we get an image. So you can see here, the first thing that we try here is to get an image. We set that image variable equal to another function here, get underscore cdn underscore image, and we pass it the product ID. So after that, you can see we've got a cascading set of nested if not statements. And I'm going to go into what each of these does here, but essentially what this allows me to do is to attempt to get the product image for that free title of the day from 3 different sources. And then each time I verify after constructing an image URL if that image is actually accessible so that I can post to Slack with it. And if it's not accessible, it falls through all the way to the bottom and winds up just using that backup image that I showed a little bit earlier. So let's talk about how I came up with this code and why I have so many different potential candidate image sources. This getCDN image function getCDN image function here on line 45, which calls this function over here on line 55, was the result of me troubleshooting issues with my program where there were some days where the program just would not post a free title of the day. And that was because my other image sources were not as reliable, and sometimes they failed. And that's what sort of led me to evolve this Python program over time, was just troubleshooting errors and finding new image sources. So I've landed on this being the new primary image source, and this one has been the most reliable. So this, cascading set of nested if not statements is very unlikely to execute nowadays, but it's there if I need it. And in previous iterations of this app, those other image sources were used a lot more. But nowadays, this one gets the free title image of the day pretty much every time. So we pass it the product ID. We've got a URL prefix of static.pact-cdn.com/products and a suffix of /cover/smaller. And then we insert our product ID into the middle in between those two things, and we return it. So if all is well, we're going to have a image URL constructed here, and that's going to work. And as I mentioned, that works most of the time for me. But what we do to verify that that image is actually available at that URL is we have this if not statement. So we say if not image available, and we pass it the image. That's going to result in a Boolean. That image underscore available function is going to return a Boolean either false or true on that image's availability. So that allows me to define here in the Python code that if the image is not available, let's try a secondary source, and we'll try that. And then we'll test that image after that with that same image available function. If it's not available, we'll try a third source, and then we'll test that one again too. And if it's not available, finally, we'll fall all the way through and just use the backup image. So it's sort of my cascading candidate images, testing them to see if the image is available. And again, ultimately, just using that backup static image if we can't find an image that's actually available to download that is pertinent to the current free title of the day. So let's look at that, that next secondary image, get secondary CDN image function, because it is possible that we fall through to that once in a while. Looking at that function over here, we pass it a details dict that we constructed above over here from that initial pact-cdn API call. And what the get secondary CDN image does, this function does, it sets an image equal to the details dictionary, there's actually a cover image dictionary object inside of that dictionary. And what we do is a dot replace on that cover image URL, replacing any spaces with %20 to URL encode that image. So this code resulted from some troubleshooting. Again, a lot of this has been iterative. Find what's broken, replace it, try a new image source. But in this case, this used to be my primary source of images, and I found that cover image uh, value uh, wasn't always accurate, or wasn't always available to download. And the value that it did contain had spaces, so we had to transform that from a space URL for an image to a URL encoded with that %20 URL encoded characters there. So after that, we do a log statement, we return the image, and then again, we would check that image's availability by calling this image available function. So let's go down and look at that image available function, because that's what tells us if that image is actually available to use before our code posts that image to Slack, or attempts to post that image to Slack. So you see here we've got a try except block in our Python code. So that allows us to capture any exceptions. If we have an issue without crashing our program, we can catch the exception here in this except block and do something else. So what we do is we pass the candidate image URL to this function. We try a requests.head method against that image URL. And then if the status code is equal to 200, which means that the image is actually accessible at that location, then we return true. And remember, this function is supposed to return a Boolean so that we can determine if that image is valid and downloadable or not. But if it doesn't return a 200, we're going to return a false, and then that's going to allow our logic above in those nested if not blocks to cascade down further into the additional ways that we can discover an image. And if we get an exception, we accept exception, we log it, and we return false. So we don't crash the program, but we return false that the image is not available at the provided image URL. So scrolling back up, we talked about get secondary image. So that was our second image source. We talked about checking if that image was available. And again, we do that for all images. Is the image available? Is the image available? True or false? And let's talk about our third potential image source, which was this get underscore shop underscore image function here. So if I scroll down to get shop image, that's here on line 67. This was actually the original method that I used to capture that free title of the day image source, and it was the only one. So long back in the day when I originally, wrote this program and I was originally doing this scraping, this is more in line with traditional web scraping in terms of we construct a shop URL, we pass it that details dictionary that we talked about above, and we pull a shop URL out of that dictionary. We construct a URL based on that shop URL, and then we log it. We use request.get to get a response from that URL. We log it. We log the response.text. And then down here on line 73, again, this is more in line with traditional web scraping, where you're downloading the body of a web page, and you're trying to do something with that body of a web page. So in this case, I used the RE, which stands for regular expression library, that's built package that's built into the Python standard library, to do a search on that response.text, on the stringified representation of that response.text that we got from that web page. And here we're doing a regular expression positive look behind. So we're searching exactly for this text to appear in that HTML body content, excuse me. And regular expression positive look behind says, if you find this pattern in the document or the text, then you can do something after it. So what I'm doing is I'm capturing, this is again another regular expression pattern here. I'm capturing anything that appears after that content, any character of any amount of lengths after that. So we're capturing everything after it, And then we are sandwiching that in a positive regular expression look behind. So we did a look ahead, and then we're doing a look behind. And essentially what we're just telling it to do here is to capture anything in between the quotes for this content equals attribute. So that's how I was originally capturing where the image for the free title of the day might be. We log what we found, and then we say if we got a match, set the shop underscore image variable equal to match.group0, and we do another logging statement here, and we return the shop image. If there's no match found in our regular expression, we just return none. And then again, that would cause our if not statement to traverse down into the backup image. But if this one was successful and the image available function returns true, then we would use this third source for the image. So let's go back up to the main function. You can see all of the complexity that is built into this program to find that image. Title was super easy, image a little bit more complicated with all of our various image sources. But eventually we get to this point where we are returning the title and then we're returning the image back to our main.py function here. And then here, back at the root of our project, we've got the title and the image variable set. So after that, we've got a set of if blocks here. We've got an if, elif, else block here that tells us what to do next. And again, this behavior depends upon what you've passed into the program to run in terms of your config options that are being parsed by that config arg parse library that I showed earlier. So originally I built this with a Slack token and a Slack channel as mandatory arguments if you wanted to post to Slack. But the reason I did that was because at the time, again, a year or two ago, Slack had published a Python client. There was an official Slack Python client that required you to use a test API token. And so this was the way to use their client. But the problem is that method has been deprecated by Slack. They no longer support test API tokens in terms of generating new ones. So you can keep using them if you have generated one long ago, but there's no way to generate new ones. So I needed another way to post to Slack. And that's where this args.slack webhook came into play. So nowadays, the way to post to Slack is to use a webhook or a Slack app with a webhook attached to it. And so I'm just going to focus on the more modern way of posting to Slack in this program. And that's from this elif block, if there's an args.slack webhook present being passed to the program. So if there's an args.slack webhook being passed to the program, then it's going to set webhook equal to args.slack webhook. And then it's going to call post with webhook.main. It's going to pass it the webhook, the image, and the title parameters. So what is post with webhook.main? Well, if we go back up to our import statements, you can see up here on line 8, we're saying from the Slack package, the Slack local package, import the module Slack with webhook. So if we go over here on the side of our file browser in our project, you can see we've got our local Slack package, and we've got this post with webhook module inside. So let's take a look at what's going on inside the post with webhook module. Up top, again, we've got our grouping of imports, logging from the standard library, requests as a third-party package. And then we've got this main function, and it accepts a webhook, an image, and a title, as you might expect, because that's how we're calling it from the main.py module that we just showed a second ago. Here we're constructing some headers. We are constructing some data as the JSON payload to post to Slack. And we are using the newer Slack block kit format for constructing our object that we're going to post to Slack. So here you can see that we've got some text, and we interpolate, concatenate the title value that we pass into the function so that the free title of the day gets an actual specific title when it gets posted to Slack in the text and also in this first block here. And then in our second block, we post a hyperlink with a link to that free learning page on Pact and some anchor text to claim that title here if you're interested in it. plus the actual title of the free title of the day. Down below, we include the image, and we've got a type of image block for Slack's block kit, and we include that image URL that we found, potentially over 3 different sources for that free title image, or that backup image if we fell all the way through. Then we do a request.post, giving it the Slack webhook, our headers, and JSON equal to that data object we created above. We do some logging, and then we're done. So what does that look like? Well, if you're in the Big Mountain Data and Dev Slack team, the Utah Geek Event Slack team, you can join the Learning Alerter channel to see what this actually looks like when it posts to Slack once per day. And I'm going to keep this running indefinitely. So if you're interested in learning about the free ebooks of the day, you can see here that we've got various titles being posted into that Slack channel daily, including a link with the title and an image for that title. So that is the gist of what this application does. One thing we haven't talked about that I'll cover briefly is my test directory. And I did learn how to test with PyTest as part of this project. I also learned, I had used previously, but learned even more so how to use virtual environments. So a Python virtual environment is something that you can create to maintain a fully isolated environment for your Python code. And I've already got a virtual environment created here, so I can just activate that virtual environment. And once that virtual environment is activated, I know that I've got the Python packages that are required already installed in that virtual environment. So I've got a requirements.txt file as part of this project, and that specifies the specific third-party packages that I need as part of this project. And I've got those installed in the virtual environment so that I don't have to install them on my system installation of Python. So virtual environments are a great way to isolate specific Python environments separately from your system Python environment. So now that I've got that virtual environment activated, I should be able to run my tests with PyTest. And I call PyTest with python-m PyTest because that allows me to organize my tests in this way where the tests can reference the packages above it in peer packages and parent modules in the directory above it. Because using python-m space PyTest does some directory context magic that allows that all to work wonderfully for you. So if I execute my tests, you can see PyTest automatically discovered 9 tests in 2 different files in the test_main and the test_packed file here. It's attempting to execute these tests, and let's give it a minute to let it be done. So it took about 18 seconds to execute those tests, 9 of them. There were 9 tests discovered, 9 tests passed. And the reason that it took a few seconds on some of them is that some of those tests are actually integration tests that make live calls out to the packed APIs that I'm utilizing. So if we go and look in those test files real quickly, I've got a test_.main file. This test really just tests that my rotating file handler has been set up as I expect it to make sure, again, that this Python program is managing the log file that it creates so that I don't run out of disk space. And it actually came in handy. A lot of people might think that you wouldn't need to test some of this logging setup, but it came in handy for me as I upgraded through a couple of Python versions. This test actually broke, and I had to make sure that this was set correctly. So I'm asserting that the type for logger.handlers element 0 is a type of logging.handlers.rotating file handler. And as you can see, that test passed. So not too interesting, but it was a helpful way for me to make sure that my rotating file handler was working. If I go into test.packed, this is the more interesting test file. And in here, you can see that I'm importing my packed package free underscore title module as packed so that I could use that in my tests. I'm setting some headers. I'm setting some get product ID test data. I'm setting some packed CDN response test data. And these were just sort of sample JSON objects from the APIs that I'm calling, just to make sure that my code was interfacing correctly with the data shape that I was expecting back from the APIs. So if we look at a few of these tests, you can see that the first test here does test get ID from JSON, where I call into my packed library module, call into the get ID from JSON function. I pass it to that get product ID test data above, and I just make sure that it can extract the product ID that I expect from that data shape defined above. I've got a test image available. No protocol should return false test here. And if you'll recall, that's that image available function where I test a head method against an image to see if that image is available. And if you don't include a protocol, generally that would produce an exception and crash your program. But if you'll recall, I had a try except block in there, so that allows me to catch that exception, log it, and just return a false. So that's that test there. Scrolling down, we've got another test here for test CDN image, returns correct URL. And again, we're just using some of that. Oh, actually, in this one, we're just setting a static product ID, and we're testing our get CDN image function to ensure that it constructs a URL that we're expecting, a concatenated URL, including the product ID that you pass it. So that's a really simple test. Another test for get secondary CDN image, and this test specifically makes sure that that %20 URL encoded image gets returned back. We've got a test get shop image when shop URL gets a match. And this is another one of those like construct an image URL that we're expecting based on the details dictionary that we're passing to it. I've got a integration test here for image available, backup image should return true. And this test is nice because it allows me to keep an eye on that backup image that I'm depending on. So if that backup image that packed hosts ever goes unavailable, this test is going to fail, and then I'm going to know that I need to find a new backup image source. Next test was test integration image available, timeout should return false. And I just am passing it a completely fake image, which should allow my timeout in my request.head image available function to timeout exception, and then that function should return a false. So that's just a test that when a image that actually doesn't exist gets passed to my image available function, that function will return a false as it should. And my last test here was test integration, get shop image when shop URL doesn't match. I'm loading some of that dummy data that we looked at above, and then I am calling that get shop image function that we went over earlier with the details dictionary, and then asserting that it should return none because the data I'm passing to it is totally fake data with a totally fake product ID. So when we call the packed web page and try to get an image out of that shop image page, there's not going to be anything there because that product ID doesn't exist. So that should return none. So I'm going to stop the presentation there, and we can take a look at any questions that may come in. So if you have any questions, I'd love to hear from you. Please post them in the BMDD_room1 channel, and we can field some questions. So thank you.
So far in the Slack room, I don't see any questions. And in the Slido room, I don't see any there either.
Perfect. Thanks for checking on that for us. If anybody has any questions and you think of anything later, feel free to reach out to me on the Utah Geek Events Slack team, or you can reach out to me on Twitter at Wesley Tech. Happy to discuss, talk about this. This project is completely open source, and so I am going to post a link to the presentation that you can download and also the source code repository for this. So if you want to get this set up for a Slack team that you're in, you're very welcome to do so, and I would be happy to help you get it set up for that as well. I think I see some people typing in the room, so we'll give a couple of minutes here just to make sure that we capture any questions if they become available.
Yep, looks like Vis wants to know if you're sharing the code via GitHub.
Yes, and I just posted a post inside of the Slack channel with the code repository. I would love your feedback. So for those in attendance, there is a link that I just posted in the room channel too. So let me know how you liked it. How was it? How did I do walking through the code? Could I have done something better? Should I have used more highlighting or drawing on the code? Should we have done Q&A in the middle of it? Would that have been better? Any suggestions you have for helping me make my presentations better would be highly appreciated. So please do reach out. I'd love any and all feedback constructively. So thank you. All right, Zach, looks like we're good to go. Doesn't look like there's any questions in. Again, if there's any other questions that pop up in your mind afterward, please feel free to reach out and be happy to discuss outside of the session.
Amazing. Thank you, Wes. Thanks, everyone.
Thanks, everybody.